Combining upper and lower bounds in 117 seconds, let's go. This is a topic which trips pretty much everybody up, guys. Let's have a look. We're told that Tom ran 100 meters to the nearest meter in 17 seconds to the nearest second. We're then asked to calculate bounds for Tom's average speed. Guys, what are we going to do? Just like with any other bounds calculation question, we're going to start off by finding bounds for our distance and our time, the two variables that were given in the question. We can see that the lower bound for Tom's time is going to be 16.5 seconds, and the upper bound is going to be 17.5, and the lower bound for Tom's distance is going to be 99.5 meters, and the upper bound is going to be 100.5. Now, where do we go from there? We need to recognize that to calculate our speed, we need to use the formula that speed is equal to distance over time. In other words, to find our speed, we take our distance and we divide it by our time. Here's where things get detailed. Now, to find the smallest possible value for our speed, we're going to need our numerator to be as small as possible. So we're going to need our smallest possible distance, and we're going to need our denominator to be as big as possible. So we're going to need our biggest possible time. We can see that this is represented in our bound by the 99.5 meters on the numerator and 17.5 seconds on the denominator. In the same way, if we wanted to calculate our upper bound for our speed, we're going to need the biggest possible distance, 100.5, and the smallest possible time, 16.5 seconds. However, one final thing to note is going to be this. Both of our inequality signs don't have the or equal to. Why is that? That's because we've used ingredients in both our lower bound and our upper bound that cannot actually be in our boundaries. So whenever we combine lower bounds with upper bounds, we need to make sure that both of our inequalities don't have any or equal to signs.